So we are dealing with the 12th problem in this series, and the problem number is 1.130. The problem is stating a body of mass m is pulled upward from the earth's surface by applying a force F varying with a height of ascent y, as F equals twice of ay minus 1 mg, where a is a positive constant. Find the work performed by this force and the increment of the body's potential energy in the gravitational field of the earth over the first half of the ascent. So if we approach this problem, so let us first draw the situation to explain the problem. So we are considering that we have a block of mass m which is resting on this horizontal ground, and this ground level is marked as y equals 0. The block is of mass m. Now it is raised gradually to a height y, which is the height of ascent, and the block of mass m reaches this point where we say that a force F is acting on it, which is given by twice of ay minus 1 mg. So now the first thing that we figure out about this force is that at y equals 0, the value of this force turns out to be minus 2 mg. So we can say that the question over here is assuming that the g value will be in negative. So if g is acting in the downward direction and hence the value of g will be negative, then we will write force equals 2 mg in the upward direction. So unless until we understand this aspect, it is difficult to consider the upward motion of the particle. So it is only possible that we understand this aspect of the problem where the question asked is assuming us, or rather want us to think this way, that if g is negative, then only F is equal to 2 mg will be in the upward direction. So if we do this adjustment over here, then we can rewrite the force in this way, that twice of 1 minus ay times mg. And over here, when the particle is at this level, then the weight of the object is in the downward direction, and this variable force F equals twice of 1 minus ay mg is in the upward direction. So if we consider this, then we can say that to attain a height y, the work done by the applied force, W is equal to integration of f dot dy, as force is changing with y, so we are writing it in integral form, and it will vary from 0 to h, where h is the height attained, and as it gathers the height h, the mass will also store in itself a gravitational potential energy which is equal to mgh. So overall we can say here that twice of 1 minus ay times mg from 0 to a height h is equal to mgh, and if we solve this part, we get twice of mg dy minus twice of mg ay dy is equal to mgh from 0 to height h. Then we attain 2h minus 2a, h square by 2 equals h, cancelling mg on all the sides, we get h equals 1 by a. So this is the first thing that we need to understand about the problem, that the particle is going to attain a height h equal to 1 by a. Now the question is asking us to find the work performed by this force and the increment of the body's potential energy in the gravitational field of the earth over the first half of the ascent. So h is not going to be the total ascent of the particle, the particle is going to rise by h by 2. So if this is to be considered as the h, which is equal to 1 by a, we here consider that the mass m is at h by 2. So therefore we can say that the increase in potential energy U equals mgh, where h is equal to 2a. So we can write it this way. And the other aspect of the problem, so this is one part of the answer, and in the second part it is also asking us to calculate work done by the force. So work done by the applied force is equal to integration of 2 mg 1 minus ay dy, and we will integrate it from 0 to 1 by 2a. So we have already done the integration till a height h. So if we substitute the values there, we get w equals 3 mg by 4a. So this is the another part of the problem. So the problem is asking us to calculate the two parts, the work performed by this force and the increment of the body's potential energy. So these are the two answers which we obtained for the problem 1.130.